Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, episode 15 of 15. Your spatial app runs perfectly on your laptop. You push it to a production server, traffic spikes, and suddenly the application silently crashes. No standard Python traceback, just dead processes. The problem is a threading clash deep inside a C library. Deploying GeoDjango applications requires avoiding this exact trap. Deploying a spatial web application is almost identical to deploying a standard Django project. The routing, the database connections, and the server architecture follow the exact same rules. But GeoDjango carries a hidden variable. That variable is the Geospatial Data Abstraction Library, commonly known as GDAL. GDAL is a massive, highly optimized C library that performs the heavy lifting for geographic data formats and coordinate transformations. Here is the key insight. GDAL is not thread safe. This explains why your code works locally but crashes on the server. The local Django development server handles requests sequentially. It rarely triggers concurrent access to the C library. Production WSGI servers are built differently. To handle high traffic efficiently, servers like Apache with mod WSGI typically spin up multiple threads within a single process. Python usually relies on the global interpreter lock to keep threads from colliding. However, C libraries manage their own memory entirely outside of Python's control. If two WSGI threads attempt to execute a GDAL function simultaneously, they access the same memory space without safety checks. One thread corrupts the data the other thread is using. Because this happens at the C level, Python cannot throw a standard exception. The result is a segmentation fault. The server process drops dead instantly, taking any active user requests down with it. To resolve this, you must change how your WSGI server handles concurrency. You need to rely on processes instead of threads. Operating systems isolate processes from one another, giving each process its own dedicated memory space. If you're pushing a highly trafficked geographic app to production using Apache and mod WSGI, you handle this in the daemon configuration. Instead of configuring a small number of processes with a large pool of threads, you restrict the threads. You open your Apache configuration file and locate the WSGI daemon process directive. Alongside the application name, you add a parameter explicitly setting threads to exactly 1. You then scale the application by increasing the number of processes to handle the expected load. The same logic applies if you use a server like Gunicorn. You must bind it to standard worker processes. You avoid any worker class that introduces threading or asynchronous event loops because they will inevitably trigger the same GDAL collisions. Forcing your WSGI server into a multi-process, single-threaded model guarantees that GDAL never collides with itself. The single most crucial step in making a GeoDjango app production-ready is isolating your C libraries from threaded concurrency. This concludes our entire series on GeoDjango and PostGIS. The best way to solidify these concepts is to read through the official Django documentation and build something hands-on. If you have ideas for what technology we should cover next, visit devstories.eu and suggest a topic. Thanks for listening. Take care, everyone.